name is Scott Shipley, head of S2O Design and Engineering, and a former Olympic team member. I create whitewater parks and design the U.S. National Whitewater Center. We're all about engineering fun. Right now we're standing right in the middle of what is the Olympic slalom course here at the National Whitewater Center. The big part of this design process is thinking about who's going to use this park, why they're going to use it, and trying to design around those needs. So coming up with ways to make it a challenge on one hand, but not the type of commitment that you can't get yourself out of on another. So one of the neat things about the way we built this course is we have several adaptable systems that allow us to change the character of the flow in between different days. So on some days it's harder, some days it's easier. One way we do that is with our pegboard system. In a matter of minutes, take what is currently a gently flowing part of the river, create a torrential hydraulic right in the middle of the course. One of the things that the science tells us is that if we pinch the water, it'll actually speed up instead of slowing down as it does with the obstacles that it pours over. So these doors allow us to adjust how fast the river goes as it goes down the course through this very, very narrow and very, very tricky section. We did that through the use of scobstacles. This is a scobstacle here. We try to make them as simple as possible so that you can adjust them day to day without having to go through an extensive process. These are simple pin systems. If I pull out the pin and pull the gate in a matter of minutes, I've made this section wider and probably slower than it would have been if I'd have left the gate narrower and faster. The park is laid out such that we have a lower pond just out of view beyond this pump station that's about 20 feet below this, which is the upper pond. These pumps are used to bring that water up to the upper pond and then flow down each of the separate channels. This pump station is what makes all this whitewater possible. This particular kayak's an interesting story. I wanted to design something that was big enough for my size, and at the same time I needed to do a senior project for Georgia Tech. And so we went in and used computer modeling software that they use for America's Cup sailboats. We created the world's first computer-designed whitewater slalom kayak. That boat went on in its first 2 races to win the World Cup Series, so a very successful design. I was also able to get credit at Georgia Tech for it. All through school, and especially in high school, you know, you would not have looked at me and said, that's an engineer, that's a budding engineer. I had trouble in math class, I struggled with my sciences, I struggled with being even interested in what was going on because it had so little, seemingly so little real-world application when you're just doing equation after equation in a textbook. When these things start to have real-world applications, even though they seem a little boring now, at the end of the day, they give you so much power to create things that people could never create without it. Being an engineer is a great thing. I mean, you're the guy that gets to decide what goes where and how this works and figure out, you know, whatever the problem is, whether it's boat speed or how much water to pump up a station. Just from that decision, from that design, you're able to create this whole water world of things to do, and I love being an engineer, and for me, it's been one of the best choices I ever made.